Good afternoon, everyone. With the blessings of God, the Almighty, and the guidance of our founder, Reverend Father Dr. J.E. Arulraj, and on behalf of the PG Department of Computer Science and Department of Computer Applications of St. Joseph's College Arts and Science, we welcome you all for the second day of our faculty development program on emerging trends and technologies using various network techniques. As we continue our journey of learning, today's session focuses on one of the most transformative and rapidly evolving technique, the Internet of Things, IoT. With the advancement in AI, 5G, and edge computing, the potential of IoT is limitless. We are delighted to have you all join us virtually for another insightful session. To begin this session on an auspicious note, let us invoke the blessings of the Almighty. I now invite Dr. M. Jayashree, Assistant Professor, Department of Computer Science, to lead us in prayer.
Prayer. Grant, we beseech thee, O Lord, that our actions with thy holy inspiration be carried on with thy gracious assistance, that every prayer and work of ours may always begin by thee, and through thee be happily ended. Through Christ our Lord. Amen.
Thank you, ma'am. To commence our session, I invite Ms. E. Yamini, Assistant Professor, Department of Computer Applications, to deliver welcome address.
A very good afternoon to all of you, and a warm welcome to all assembled here for the 5-day faculty development program. I extend a gracious welcome to the inaugural ceremony of FDP on recent trends in IoT. It's my pleasure to welcome our administrator sister, Dr. M. Baby, and our principal, Dr. R. Ruben, who continuously supporting us to various events and seminars. I extend my welcome to our today's resource person, Dr. V. Raghavendran, Assistant Professor, Department of Computer Application, Wells in the Institute. I welcome our beloved HODs who organized the 5-day faculty development program. Once again, I welcome all.
Thank you, ma'am. It's now time to introduce our today's resource person. I request Mrs. R. Tayamal, Assistant Professor, Department of Computer Applications, to give an introduction.
I am privileged to introduce about our today's resource person, Dr. V. Raghavendran. He is currently working as Assistant Professor in the Department of Computer Applications, Wales Institute of Science and Technologies and Advanced Studies, Chennai. He has completed postdoctoral fellowship from Maxim University, USA in December 2023. He has completed PhD from Madras University in 2021. He is having 20 plus years of experience in various institutions in India and abroad. He has been working as a researcher more than 10 years. He has published more than 30 articles in national and international journals. He has presented more than 20 papers in national and international conferences, and he has published 3 patents. He has published 10 books and 6 book chapters in computer science and application stream. He was the chief executive editor for the book Evolution of Federated Machine Learning, Volume 1, 2, and 3, released in July, August, and September 2023. He is guiding 4 PhD research scholars at present. 2 of them submitted their synopsis, ready to submit thesis report. He has received the Best Teacher Award in 2007 and Best Faculty Award in 2022. His research areas are IoT, machine learning, data mining, image processing, cloud computing, and blockchain. We have such a wonderful resource person today. We are happy to have you here, sir.
Thank you, ma'am. Now, as we delve into the core of today's session, I'm pleased to invite our resource person, Dr. V. Raghavendran, to take over the session. Sir,
Good afternoon, ma'am.
good afternoon. Good afternoon, sir.
Can you hear my voice, ma'am?
Yes, sir, audible.
Yeah. Thank you so much, ma'am, for inviting me for the 5-day FDP Faculty Development Program. This today is a very interesting topic, a recent trend in IoT. Can I share the screen, ma'am?
Sure, sir.
Is it visible?
No, sir.
I have shared the screen, ma'am. Is it visible to all?
No, sir, not visible.
Ma'am, I have connected with two, like my laptop along with the mobile, two Raghavendran, ma'am. And once in laptop, I have shared the screen. Can you check it, ma'am?
Sure, sir. We are checking. Few minutes. We are unable to see your presentation, sir.
Check it, ma'am, now.
Yeah, yeah. Yes, sir.
Now,
It's
ma'am,
visible.
it's
Yeah, it's
okay?
visible, ma'am. Visible, sir.
Yeah, good afternoon to one and all present here. It's my privilege to be a part of this faculty development program, a recent trend in IoT. So today we are going to discuss about the following things. Uh, Definition, history of IoT, scope of IoT, IoT architecture and framework, example, IoT ecosystem, broad research direction, how IoT works, the structure of IoT, and many advanced concepts in IoT. Everyone can see the screen. Some screen is scrolling, ma'am. So first of all, we'll see the definition of IoT. So internet, everyone knows about internet. It's a network of network. But thing is nothing but object. So normal object also can be converted into a smart object with the help of Internet of Thing IoT. So basically, it is a network of physical object embedded with electronic software, sensor, and network connectivity, which enable these objects to collect data, to sense data, and exchange data among different objects.
Excuse me,
Because of this collection, this sensing of data,
excuse me, sir.
it can be,
Hello.
yes,
Excuse me,
yes,
sir.
ma'am.
Sir, the slide is not moving,
Ma'am, I am scrolling on only, ma'am.
but we couldn't
You,
see. Sir.
you couldn't see? 1 minute, ma'am, I'll check it. You can check now.
Yeah, we're checking. Sir.
Now it's working. Now you can see.
Not yet, sir.
1 minute, ma'am.
Yes, sir.
Now it's visible, ma'am.
Yes,
It's
sir.
visible.
Yeah. Now it is visible, sir.
I can make it as full screen.
Yeah, yes, sir.
Is it visible to all?
It is visible, sir. But
Yes, ma'am. Yes, ma'am.
okay, sir. But it's not in slideshow, I think. Yes, sir.
No, slideshow. I made it slideshow, ma'am. But it's
Okay.
coming. In your screen, it's coming, ma'am.
It's okay.
I made it slideshow.
Okay.
Is it okay?
Yes, sir. Thank you, sir. Thank you, sir.
Yes, ma'am. So to make any normal object to be a smart object, that object can sense the data. It may be near devices from far devices, and it can be controlled remotely across existing network infrastructure. So this integration of the physical world between the computer-based system, that will improve the efficiency, accuracy, and economic benefit. The thing in the sense, in the IoT sense, we can refer to a wide variety of devices. That devices can be a heart monitoring implant, biochip transponders on farm animals, electric clamp in coastal water, automobiles with built-in sensor, DNA analysis devices for environmental food pathogen monitoring, or field operation devices that assist firefighters in search and rescue operations. So these are all the many devices are there. These devices now it becomes a smart devices, so that it can be connected with the internet and it can sense data remotely or from local devices or through anywhere else. Those devices can collect data and it can be given to the cloud, and cloud will perform the remaining operations. So the history of IoT, the Internet of Thing word became very popular in 1999 through the Auto ID Center at MIT, related to market analysis publication. The first object is going to be a RFID, radio frequency identifier. It is a prerequisite for the IoT at that particular point of time. So if all object and people in daily life were equipped with identifier, computer could easily manage and inventory those things. So beside RFID, later many tagging of things may be achieved through technologies that can find near field communication, barcoding, QR coding, Bluetooth, and digital watermarking. The scope of IoT, the broad scope of IoTs are given below. It may be for communication, cooperation purpose, addressability, identification, sensing, actuation, embedded information processing, localization, user interfaces. The architecture and framework of IoT basically consists of four layers. The first layer, you can call it as a device layer. It consists of all the devices, which is a part of sensor and actuator. The second layer, you can call it as the connectivity layer. The connectivity layer will connect more than one devices together. So we need a network and we need a protocol to communicate with each other. The third layer, you can call it as a data processing layer. So whatever data we have connected, communicated among self, that can be stored in one particular area called cloud. We need many edge devices to process those data. And the last part of the layer, you can call it as an application layer. It is from the user point of view. All the user interface or user applications will be present in this particular layer. So these four layers are very important when we are discussing about the IoT architecture. So the first of all, we'll see the device layer, sensor. So everyone knows about the sensor. So sensor will sense information from the environment, and those information will be fed into the computer system for further processing. So there are many types of sensors are there. I have given few examples. Temperature sensor will sense the temperature in a particular area. Light intensity sensor will detect the intensity of light, whether the light is going to be a huge or dim, or it may be moderate. Pressure sensor will measure the pressure in a gauge, in a gases or liquid. Motion sensor will recognize the motion in an established region. Then the next device in the device layer is an actuator. It is just the opposite of sensor. So actuator will fed in input from the system, and from the system that can be processed and given as an output. So sensor from the environment, the input are fed into the system, but actuator from the system, whatever thing is generated, processed, that will be given to the environment. So actuator actually is a device which gives output to the environment. There are many types of actuators out there. Linear actuator will utilize a linear motion to convert energy. It may be a kinetic energy or it may be any other energy. So rotary actuator will find the motion of the rotational object. Hydraulic actuator will find the fluid power which gives the motions. And pneumatic actuator which uses the compressed air. Then, as we said, connectivity layer, whatever data sensed by the sensor that can be stored in a place called a cloud infrastructure. So the cloud infrastructure will be connected with the sensor through this particular layer. The connection may be established in any way through any medium. It may be a satellite network, it may be a Bluetooth, it may be a Zigbee, Wi-Fi, WAN, it may be any form of the connectivity. Processing layer. So whatever data is stored in the cloud that can be collected whenever it is needed, that can be processed, and accordingly whichever user is needs information, that information will be given to that processed data will be given to those particular users. So this process can be just checking like the temperature reading on device like the AC or heater, etc. So it can sometimes also be very complex, like identifying an object using computer vision on video. Or data processing layer will make use of the edge computing, where data is processed close to where it is generated, or through cloud computing, where data is transmitted to centralized server for processing. The fourth layer, user interface layer, where user can see the form design or user interface, where user can give input, can get output. It may be in the form of a triggering alarm on their phone call, or it may be in the form of a notification, or it may be in the form of a text message. So for example, the user has a camera installed in his home. He wants to access the video recording, whatever things happening in their house, and all the feeding with the help of those web camera through this IoT, we can able to establish all this thing. Then the real-time examples of IoT, see a light bulb that can be switched on using your mobile phone. And as a motion sensor or smart thermostat in your office or a connected street light. An IoT device could be as fluffy as a child toy or as serious as a driverless truck. Some large object may themselves be filled with many smaller IoT components such as a jet engine that's now filled with thousands of sensors collecting and transmitting data back to make sure it is operating efficiently. Apart from that, here I have given an example from generic electric system which deploys sensor in its jet engine, turbines and wind farm. By analyzing data in real time, GE saves times and money associated with predictive maintenance. So it consists of three parts. So first part is going to be the connectivity, second part is going to be the cloud area, and third part is going to be the user applications. So everything is going to be combined together to establish successfully how the IoT data is going to be sensed, processed, and it can be given to the users for further processing. Uh, Now we'll see where we are now in the IoT in 2025. So the first part of IoT established through between two host systems with the help of a network. The next generation started with the internet concept, how many networks are combined together to establish and access public related information. The next generation started with the mobile internet. Not only system, even mobile devices also can be act as a host, can be act as a communication medium that can send data and receive data through different hosts. And now we are in this particular stage, mobile phone along with people, PC, where everything is going to be connected. Not only mobile phone, not only PC, even any normal object, even we can use washing machine as an internet of thing. It can be connected with the Wi-Fi. Even normal devices, fan also we can connect it with the mobile devices, so that we can switch off through our mobile devices. So the current generation is comes under the internet of things, where everything is all normal object also can be programmed and act as a smart things. So Internet of Things makes a normal things, normal object to act accordingly as a smart object. So we are in the era of Internet of Things currently. Next is IoT ecosystem. So in the IoT ecosystem nowadays we are having many wearable devices. That wearable devices will be connected with sensor, and this sensor will act as a things efficiently. And this particular wearable devices connected to the intermediary communication and processing devices, and gets data and send data to the cloud for real-time processing, and those data can be visualized, presented, and it can be recommended whichever way user expect as output. So finally, whatever is stored in the cloud will be archived for safer purpose. So this is the IoT ecosystem. So in this IoT ecosystem, it consists of a number of components. Some components belongs to the IoT part, some component belongs to the application part. So the IoT part, you can call it as a device manufacturer, consists of sensor, actuator, and the smart application. The next part is going to be network service provider. Cloud service provider will be acting as a mediator between the IoT and between the application, user application. So user application, it may be a third party application, or it may be any application that can connect it with cloud, that cloud itself connected with any smart devices to get data. In the broad research direction, starting from the earliest year before 2010 till now, various hardware and software processing components required for IoT is given in this particular slide. So I have given a short description about that. In before 2010, we need a hardware called RFID. So those RFID, radio frequency identifier, is used for tagging, is used for sensing data. In 2010 to 20, we need a special protocol consists of multi-standard readers. That readers will make use of sensor and actuator acting smartly. In 15 to 20, this smart sensor become a biochemical sensor, or more tiny sensors. Even the size of sensor is going to be very, very miniature size, so that we can equip anywhere in the system. After 2029, nowadays we are in this particular era, we are using a nanotechnology concept and make any new material that can be act as a smart object. So the data processing stage in 2010, before it is a serial data processing. Nowadays we are processing data in a cognitive way. So cognitive processing is the main idea of a nanotechnology. Then the network point of view, before 2010, we need a sensor network, but nowadays we are equipped with any types of network. That network will cognitively self-learning, self-repairing network. So we don't require any human intervention. Even by itself, the sensor reads the situation accordingly. It acts. And software and algorithms required nowadays is going to be a user oriented software, and it may be consist of things to human collaboration. So we need a human and thing collaboration. So these are all the research directions starting from 2010 till 2020 and beyond. Next, we'll see how IoT works. So initially, as I told, IoT, the first IoT started with RFID. So this RFID is used to identify and track data of anything. Then this RFID sends in the form of sensor to collect and process the data to detect the changes in the physical status of things. Then the sensor become a smart technology to enhance the power of the network by devolving processing capabilities to different part of the network. And recently, nowadays, we are in this particular era, we are using nanotechnology to make the smaller and smaller things have the ability to connect and interact with the computer system. Next, the structure of IoT. So IoT structure, it may be mini, it may be macro, it may be major big size devices. So the IoT can be viewed as a gigantic networking consisting of network of devices and computers connected through a series of intermediate technologies where numerous technologies like RFID wireless connection may act as an enabler of this connectivity. So it is broadly divided into four things: tagging things, feeling things, shrinking things, thinking things. So tagging things, we are using RFID as a major device. Feeling things, we are using a sensor as a primary device. Shrinking things, we are using a miniaturing nanotechnology. Thinking things, we are using embedded intelligence in devices through sensor, which form the network connection to the internet. It can make the things realize the intelligent control. Now IoT as a network of network. See this diagram, it consists of many areas where they can benefited with the IoT. So it may be everything is collaborated with the network, and each network is communicated with each other properly with security and analytics and management. It may be any application that can be easily integrated together through this particular Internet of Things, and we can give security and we can analyze those data, we can manage those data easily. Next, knowledge management. As we all know, our knowledge management starts from the basic things called data. So data, maybe we know it is a raw fact. It may be in the form of any symbols. Then collection of those data, we can call it as information. So through this information, we can easily answer who produced this information, what type of information, where this information is required, and when this information is going to be used. Then when you collect those information, useful information, we can produce knowledge. So this knowledge is going to be when the particular knowledge is going to be applicable to solve the problem. So after this knowledge, once the knowledge is going to be gained, we can understand how the particular knowledge is going to be used to which categories of problem. And finally, the last thing is going to be wisdom. So wisdom is going to be the highest level of data processing. So it is evolutionary in indexing. So it is understanding of those particular data which can be applied to a particular problem efficiently, and we can give solutions to any complex problem. See this diagram, the future of IoT. See when what happens when 50 billions of missions become connected. So this is the recent area where IoT is playing the major role, that you can call it as the industrial internet. So the industrial internet consists of smart home, it may be smart hospitalization, it may be factory operation, it may be any particular area. Everything is connected through this particular cloud infrastructure, where everywhere we are using the IoT devices, those devices connected to each other. So that's why I mentioned 50 billions of missions connected and sensing data. That data can be processed, it can be shared, it may be communicated through any particular medium. The potential of IoT. So the value of industrial internet is going to be very huge. See, in the industry, you can call it as aviation, power, healthcare, rail, oil and gas. The usage of Internet of Things and producing data is going to be listed here. So 30 billions of data is going to be used in the aviation is an estimated details. Same way oil and gas, it's going to be 90 billions. So connected missions and data could eliminate up to $150, 150 millions billions in waste across industry. So we have more data sensed by the devices, but we are using those data for a useful purpose that we don't know. So unlock the massive potential of IoT. It may be because of IoT, the performance is going to be much higher, and we can reduce the cost of devices, and we can generate new revenues. We can create innovative services to many industries. These are all the technological roadmap of IoT. So IoT start from us, as I told, start from RFID. Nowadays we are using many teleoperational devices, nanotechnologies. So these are all the way. It starts from the lowest level till the highest level. Accordingly, nowadays we are using the particular IoT and the devices in any format. It may be a small size, it may be a huge size, it may be any size that can be used according to the particular problem. Major benefits of IoT to organization. Organizations are using IoT to monitor their overall business process, for improving the customer experience, to save time and money, to enhance employee productivity, to integrate and adapt business model, to make better business decision and generate more revenues. So the corporate aspect of IoT benefit to the organization is, so IoT, it is going to be transformational force that can help company to improve performance through IoT analytics, IoT security to deliver better results. All the business enterprises in the utilities, oil and gas, insurance, manufacturing, transportation, infrastructure, and retail sector can reap the benefits of IoT by making more informed decisions that can be aided by the torrent of interactional and transactional data at their disposal. Not only these benefits, IoT platform can help organizations to reduce costs through improved process efficiency, asset utilization, productivity. The growth and convergence of IoT processes and things on the internet would make such connection more relevant and important, create more opportunities for people, businesses, and industries. Why IoT nowadays is going to be very important. So it becomes one of the most important technology in the current century. We can connect any object. It may be a kitchen appliances, it may be a car, thermostat, baby monitor, to the internet through the embedded devices, which can be used for seamless communication between people, processes, and things. So nowadays, these devices produces low-cost computing, cloud, big data analytics, mobile technologies, physical things can share and collect these data with minimal human intervention. See the current status and future prospect of IoT. So in 2003, usage of IoT only 6.3 billions and 500 millions of connected devices were used. But in 2020, it may be 7.6 billions and 50 billions of connected devices are used. Because of that, every person is involved directly or indirectly. We are using this IoT technologies which make use of many devices, not only single device, which make use of many devices. So by the year 2027, there will be a lot more connected devices than people on earth. So this is a gateway to the future. So this cloud and service platform will be connected with the IoT concept to generate a smart city, smart hospital, smart highways, smart factory. All this thing clubbed together, the data can be delivered, the data can be used for solving any types of problem. You can call it as it is an intelligent digital signature. So applications of IoT, there are many applications, there are many areas, many industries where we are using this IoT concept efficiently. It may be education, management, retail, logistic, pharmaceutical, food, and many more. See this particular area, the successful implementation of IoT in the area called smart home. So nowadays, the first number, the rank one is given to smart home, where the IoT concept is utilized most probably 100%. Next, the wearable devices, then the smart city, then the smart grid, industrial, internet. These are all the applications where making use of this IoT concept nowadays. Now still it is improving. Even smart farming is nowadays, many people comes to know about the smart farming and smart supply chain management, smart retailing. All smart concept is evolving nowadays. See, IoT, which is used in diverse application, it may be home consumable, it may be transport mobility, it may be health body, it may be building infrastructure, it may be city industries. So any areas we can successfully use this IoT concept. Accordingly, people, devices, information can be collected, used for many application purpose. See here, smart parking. So even small areas of space can be 100%, 200% we can utilize. See, create it US dollar of 41 billion by providing visibility into the availability of parking spaces across the city. So residents can identify and reserve the closest available spaces. Traffic warden can identify non-compliant usage, and municipalities can introduce demand-based pricing for parking areas. So we can make use of this parking, small size parking areas in an efficient manner. Next, the efficient waste management in smart cities supported by a sensing as a service. So we have know about software as a service, platform as a service. Because of IoT, we are going to the next era called sensing as a service. Here we have many pointers given. So the first point is going to be even the waste dustbin can be connected with the sensor, so that the truck will get, if the dustbin is going to be full, the message is given to the truck. The truck can come and collect those things, and those things can be separated accordingly, and all these details will be stored in the cloud. Apart from that, even that road lights can be automatically switched on, automatically switched off through the solar rays, and those powers can be consumed and used for many other purposes, many other home purposes, many other related public service purposes. So sensing is going to be the major advantage of using IoT, especially in the waste management, in providing smart cities. Next, very important application, sensor, even we can embed it in the holy cow. See, in the world of IoT, even the cow will be connected and monitored. Sensors are implanted in the ears of cattle. This allows the farmer to monitor cows' health and track their movement, ensuring the healthier and plentiful supply of milk and meat for people to consume. On average, each cow generates about 200 MB of information per year. Even now, cow become a smart cow, embedded cow, and that can generate a huge information for additional processing. Next, IoT application scenario, even in the shopping mall. So in the shopping mall, the first thing, when you are entering into the shopping mall door, the scanner will identify the tags on the clothes. Second, when you are going for shopping in the market, the goods will introduce themselves. So whichever area you are planning to buy, the goods will tell. So this particular area, these are all the things are there. You can move to that particular area directly. Third thing, when moving the goods, the reader will tell the staff to put a new one. If it is over, people are demanding for that particular goods, immediately the message will be given or triggered to the corresponding persons. Then the goods will be stored in that particular area. The demanded goods will be filled automatically with the help of triggering messages. And the last part, when paying for the goods, the microchip of the credit card will communicate with the checkout reader. So even in shopping, it is going to be IoT. It's going to be used efficiently so that no one can monitor physically. Even the devices will monitor everything. Next, see our sleeping mechanism. How well do I sleep? See, when you are moving to the bed at 11 p.m., we are wearing the sensor equipped watch. So that sensor equipped watch will monitor how many hours you have slept, how many hours you went for deep sleep, how many hours you are lying on the bed, how many minutes you are thinking and not sleeping 100%. So everything can be easily monitored with the help of a device, smartwatches. These smartwatches will be used for even we can find ourselves whether
Ma'am, is
you
the
will.
session over?
No, ma'am, it's going on. How the smartwatches will monitor the sleeping habit of any human being. We can find out whether you went for good sleep or it's not the halfway sleep. Then I want to know more about myself. Even nowadays, many devices are there, and you can ask question to these devices where you are going, who you are interacted with, how long you have spoken to friend, the affinity of collections, how long it takes to get work, the tones of your messages, the amount you texted, tweeted, and updated, how much exercises you are getting every day, how much you get distracted. Even the devices will easily monitor your feeling also. Your feeling, whether how much time you are laughing, feeling sad, everything will be monitored. Next, next important computing called thought controlled computing. So this particular device you can wear as a is in your head. The flagship product produced by the Wave is a headset that can log into your computer using just your thought. The recent researchers use the EEG headset to develop a toy car that can be driven forward with thought. So NeuroSky's smart sensor can also track your heart rate and other bodily metrics and can be embedded in the next generation of wearable devices. So we make it possible for millions of consumers to capture and quantify critical health and wellness data. These are all the data collected from Yang, CEO of Scott Bank, and SoftBank is a funder. So even what thought you are, which particular mood you are, easily can be tracking by the devices. Next, technological challenges. Even though IoT gives more benefit to the people, to the organization, to the industry, even we have some challenges. The challenges are scalability, technological standardization, interoperability, discovery, software complexity, data volume and interpretation, power supply, interaction and short range communication, wireless communication, fault tolerance. IoT, we are not making use of IoT as a separate industry. We are making use of IoT along with the mini concept called big data, cloud infrastructure, machine learning, AI combined together to make use of IoT in an efficient manner. That's why it is given. Big data is not a magic. It doesn't matter how much data you have it if you can't make sense of it. We can generate a huge amount of data, but those data, how we are utilizing for useful information to the public. The criticism and controversies of IoT. Many scholars and the social observers and pessimists have doubt about the promises of the ubiquitous computing revolution in the areas such as the privacy, security, autonomy, control, social control, political manipulation, design, environmental impact, influences human moral decision making. Some solutions to the challenges what IoT is facing. So several solutions are proposed to overcome the problems. They are overcoming compatibility issues is a significant IoT hurdle, but emerging companies are starting to enable increased interoperability through open source development. The government and industry body needs to set standards and regulations for the various industries to ensure the data is not misused. Even IoT needs strong authentication methods, encrypted data, and a platform that can track irregularities on a network. The conclusion: the projections for the impact of IoT on the internet and economy are impressive, with some anticipating as many as 100 million connected IoT devices and a global economic impact of more than $11 trillion by 2025. The potential economic impact of IoT is huge, but the journey to IoT adoption is not a seamless one. There are many challenges that face companies looking to implement IoT solutions. However, the risks and disadvantages associated with IoT can be overcome. These are all the references I have made to prepare this PPT. Thank you so much. Do you have any queries? Ma'am?
Yes, sir.
Yes, ma'am. I have completed, ma'am.
Yes, yes, sir.
Yes.
Thank you, sir. Thank you so much. Your
Thank you, ma'am.
expertise and in depth knowledge have truly enriched our understanding of this evolving domain. Your presentation has provided us with a perspective on how technology is shaping the future. Thank you, sir. Thank you so much. Thank you for
Thank you,
this
ma'am.
insightful
Thank you,
session.
ma'am. Thank you, ma'am.
Dear faculties, kindly turn on your video for the photo session. We appreciate your cooperation in making this moment memorable. Thank you all. Now it's time to express our gratitude. I'd like to invite Dr. N. Nirmala Devi, Assistant Professor, Department of Computer Applications, to deliver the vote of thanks.
Good evening to everyone. I extend my sincere gratitude to our esteemed founder, Father Dr. J.E. Arulraj, for his continuous support. Then I special thanks to today's resource person, Dr. V. Raghavendra, Assistant Professor, Department of Computer Application, Wells Institute of Science and Technology and Advanced Studies, Chennai, for sharing valuable insights and your in-depth knowledge in IoT. Next, my heartfelt thanks to our administrator, Reverend Sister Dr. M. Baby, and our beloved Principal Dr. R. Ruban for encouraging us throughout the planning and execution of the FDP. Next, I thank all the participants who passionately supported us and enriched the discussion. Finally, I extend my gratitude to all the HODs, program coordinators, faculties, and the technical team. Thank you all.
Thank you, ma'am. Thank you, ma'am. Shall I leave, ma'am?
Yes, sir. Thank you so much.
Thank you, ma'am. Ma'am, please share the feedback link, ma'am.